Good morning, everyone. My name is Uday Kamath. I work as the Chief Analytics Officer for Smarsh. Um, or I can see the timer here. In last 4 to 5 years, we have put like hundreds of machine learning models, especially in speech and language, that map to the regulatory world, especially in conduct surveillance and supervision. And today, I wanted to go at very high level from regulatory risk and what we call as the regulatory grade AI. What should it contain? What are the gotchas, pitfalls? What are the things that we have learned and want to share those experiences and some high level principles in developing this regulatory grade AI. Working with one of our partners, Correlatics, we had built this kind of like regulatory risk to compliance mapping, especially in the financial world. And it's a matrix of various regulatory components from market conduct, financial crime. You can see fraud, anti-money laundering in market conduct. You can see insider trading, market abuse, market manipulation, different regulatory risks. And the color coding is kind of like the sensitivity from the financial institutions. That is like the darker it is, uh, more the risk is. And it is based upon the penalties, it is based upon the severity, litigations, the dollar value, lots of aspects to it. And you can see that market conduct, financial crime. It is done 2, 3 years ago. That's why like cybersecurity is somewhere lower in the risk. But today the cybersecurity, if you see, has higher risk to it. What we see that even though regulatory world cares about the regulated aspect of the risk, it's also the unregulated part of it. Like you need to monitor both in your policies, the regulatory, because managing, mitigating these policies are one and the same, whether it is regulated or unregulated. And that is the key part. So each financial institutions carry their own business policies, how to monitor it through their supervision surveillance programs, how to manage it and mitigate it. They use different vendors, including Smarsh and many others. That is based upon like evidences. Some of them are weak evidences, like behaviors. Some of them are very strong evidences. And finally, it results into, for some reason, I could not see the implementation here. How do I go back? How do I go back? Okay, it's delayed. So the evidences can be strong evidences, or especially from misconduct. If you can see the FINRA, SEC, you can see different kinds of misconduct. You can get pointers about the text, about the speech that happened, and use that as your seeds. Then you have like weak evidences. And that's where it gets tricky. That's where machine learning and AI comes into picture. And there are two options for implementations, two extreme options. But I always say that the answer lies somewhere in between. On the extreme side are what traditional people do, that is rules as lexicons. I'm talking about more of natural language or transcriptions from speech and then applying machine learning on top of it. Rules or lexicons were the ways people monitored the traditional system. On one hand, they are extremely explainable to some level based upon the complexity of the rules, but they result in very high false positives. They are difficult to maintain. They don't go across languages. The idioms are difficult. On the other side, machine learning models are what like many people are going for, but you need to think about, like as Natish was going through his presentation, many aspects of machine learning models. Where does the data come from? You have to think about the regulatory side all the way. Is it explainable? Is it interpretable? Are you able to separate out context from content? How are you mapping these behaviors to the content? What are your machine learning models? So I gave a simple illustrative example of just putting like a behavior to track market abuse in terms of secrecy. Are you kind of like exchanging secret behaviors? And in simple word, you can put lexicons, look for words like hush, quiet, and add it to your rules. On the other side, machine learning model can be much more generalizable, where you can add things like samples to your data. And it need not be restricted just to the keywords over there and can generalize. Once we see that machine learning models are the key towards the utopia of like reducing false positives and increasing efficiency and finding that interesting true positives, as Nitish said, like many of them fail. And this was from the Gartner report, and there have been McKinsey report and many reports that suggest like 80 to 88% of machine learning models don't see the light of the day. They are in the experimental stage. And that's because, I think, again, Nitesh pointed out, it touches various aspects of unrealistic goals, ill-defined problem, and poor ML process. Now, the same part of unrealistic goals, not having your stakeholders, that is data scientists, subject matter experts, your regulatory aspect, all together and saying like what exactly is your success criteria? What are you mapping your policies to the machine learning models? What is your outcome you are interested in? Do you want to reduce false positives? Do you want to increase efficiency across the different modes of communications? What are you looking for? Mapping that goal to the machine learning metric, as Nitish pointed out, is the key step. And it has to be iterative. You can't have like the best machine learning model day 10 of your process. It goes through an iteration, because you will learn, you will understand the fail states, and then you will iterate and build a better model. Ill-defined problems. Another thing that we have seen is like you can't use machine learning model to everything. Like that has become a trend that you see something from the academic world and you throw machine learning to it. Is the problem atomic and can be solved by machine learning? Does it have sufficient real world examples? Because this is another interesting thing we see, like in various communication intelligence compliance failures, for these behaviors are anomalies. There are like 1 in 1 million. To build machine learning models, if you take like the state of the art machine learning model and say that I want to fine tune it for this, you would require at least thousands of examples. Where are you getting your data for? Synthetic? Does it map to the real world in that case? How are you building your data sets in that case? So all of this results into kind of like the failure states. And finally, the poor ML process. Do you have imbalanced data? 1 in 1 million. Does that reflect in your testing? Do you have biases in your data? Like, I think it was asked as a question, like in regulatory world, you need to think about the biases from gender, ethics, religion, many aspects before promoting it, especially in speech and language. Again, the choice of the model, simpler model, Occam's razor, interpretability, explainability, All of this becomes an important question. And finally, the monitoring and observability part of it. So once we see that machine learning models are what is needed, we also see that it is very hard to promote an experimental model into machine learning models. What we define as the regulatory grade AI is kind of like a balance between the two trade-offs. And the trade-offs are agility and stability. On one hand, you have to cater for the agile changes in technologies. Every third week, there is a new machine learning technique, deep learning model, state of the art with 540 billion parameters. There are new forms of regulations from misconduct for cybersecurity and uh, all kinds of institutions trying to put new kinds of ways to look into and monitor the population. On the other hand, you want stability. You want to make sure that the policies that you look for into mitigating risk are stable. You are not overwhelming your investigators with tons of false positives, and at the same time, you are making sure that it is working better than your traditional system. It is not missing important things because that is bound to have penalties. Are there risks and biases in your models? So maintaining that balance between agility and stability is what like the panacea of regulatory grade AI is. And the question is how to achieve it. In our view, there are three phases: design, development, and monitoring. And I think it is something very close to what Nitish had in his presentation, because it is nothing what we have invented. We have just been through this through hundreds of models and machine learning through our customers that we have learned it. Design phase, as Nitish was saying, is the key phase where most of the time is being spent, where from the financial world, from the regulatory world, you need to be very clear and have a documented process. How did you acquire the data? What were the sources of the data? Where the data gone through pre-processing? What forms of pre-processing? What forms of bias were discovered in the data? And the measurability part of it, like what are the performance metrics? How does that performance metrics map to the business? And how are we tracking it down from the basic system to the production system? Explainability is my favorite topic. Of many books I have written, explainable AI, especially interpretable machine learning, was released 6 months back. Thinking from the practical world, where I have gone through all of the deep learning, statistical machine learning, and other techniques, and introduced both the practical side of it and the theoretical side of it, and how to measure, how to have an explainable systems. Because for the regulatory world, it is not about just the quality. It is that trade-off between quality and explainability. On one side, you have the compliance team who focus on quality. They want reduced false positives and high quality models. But the model risk management and the governance side care about explainability. They care about interpretability. They have to worry about explaining it to the regulators why this alert had been generated. And even though there is a trade-off, I think what our experience has shown us is you can get a better trade-off by working on simpler models, interpretable models, iterative way, and achieve that explainability. And it was demonstrated in one of our papers quantifying explainability in NLP, and analyzing algorithm for performance explainability trade-off. And here, the same secrecy, which we moved from traditional rules to machine learning models through two different worlds. One is a simpler logistic regression model, and one is a neural network model. And different layers are being shown over here for a local example over sentence like plenty of people know this now, it is no secret, where we are trying to track a secrecy behavior in the regulatory world. And here you can see kind of a clear global coefficients. Now again, explainability and mapping the coefficients to correlation and causality is a separate topic, but at least you know globally why things are happening over here, whereas here you need another model like LIME, SHAP, or other techniques to actually work on to say why this has happened. And it is like turtle on another turtle. And that's where like you need to be very, you need to understand like what models you should get into right at the start, not only meeting the quality part of it, but the regulatory side of explainability and interpretability. The next phase is what we call as the development phase, which is like to go through the various aspects of, okay, I'm able to separate out true positives and false positive through explainability and interpretability, but have I tested for biases? Have I tested for fail states? What are my fail states? What happens if I change the gender? What happens if I change the nouns? What happens if I change the verbs? What happens if I change the locations? So these kinds of testing for stability, robustness, where my hyperplane in the model is and how it shifts the variances in the model and data is one of the important testing phase. That is, not only you have to test for separate out like in machine learning world, training, validation, and test, but do a realistic testing from regulatory side of the world. Because especially with speech and language, there are so many modes. You can say the same thing in many modes, and different accents, different colloquialism, different idioms. So understanding that and using it in your robustness testing and stability testing is a key thing. And finally, like apart from like the different from the software engineering process, once your model goes into production, you don't just look for the bugs. You have to actually do a constant observation. You need to understand the data drift, the label drift. You need to understand how your metrics are changing. You have to employ some form of statistical process to see how the variations change over time. There are various tools over here, but that is one of the most important things. That gives you an insight of when to actually train and tune your models. It can't be predetermined, but observation has to be continuous. When you train and test your models and do next iteration, changes over time. And the final part, like the operational part of it, most of us care about like the inner side of things, like going from business goals, framing it as machine learning problem, processing the data, deployment, and monitoring. But the outer part is also important. That is where the platform comes into picture. You need a platform that provides you efficiency, performance efficiency, SLAs, that this many messages have to be processed in this much time. Reliability, if something fails, it has to be reprocessed. You need to make sure that security, auditing, optimization, all of that are guaranteed in the platform. It is just not like the machine learning process, but the outer part of the circle too. Ensuring that all of this is taken care of gives you an operational regulatory grade AI. So that was my talk. If you have any questions, I'm here to answer.